All right, finally out of Chapter P and into Chapter 1. This is Chapter 1, Section 1, Graphs and Graphing Utilities. There was this gentleman whose name was René Descartes. You spell his name D-E-S-C-A-R-T-E-S. Descartes. He was French, developed a branch of mathematics that brought together algebra and geometry in a unified way, a way that visualized numbers as points on a graph and equations as geometric figures. You know, like a line or a parabola or a V-shaped graph for your absolute value. We graph on a rectangular coordinate system. Now let me tell you, all graphs that you do must be on Cartesian coordinate paper. Cartesian coming from Descartes' name, C-C-A-R-T-E-S. All right, so that is part of the word Cartesian. So it was named after René Descartes. So you must use graph paper or Cartesian coordinate paper for all graphs. Please don't make your own little makeshift graphs. You must use graph paper. All right, the point of intersection of the x and the y axes is called the origin. Now, normally, if we were doing this live in class, I would be asking you these questions. The plane is divided into 4 quarters called quadrants. And I will let you fill in where's quadrant 1, where is quadrant 2, where is quadrant 3, and where is quadrant 4. Well, the upper right-hand corner is quadrant 1. To the left of it, we go counterclockwise, quadrant 2. Below it, quadrant 3. And finally, quadrant 4, Roman numerals. So we're going to use IV to mean 4. And we will identify the intersection point of the 2 axes and say that is our origin. I don't know if you've ever thought of the coordinate plane as 2 number lines, but it is. This is my x number line. This really should have arrows on it. And over here. This is my x-axis, or my x number line, right? The negatives to the left. But if you think about it, the y-axis is really a number line as well. So if I turned my paper this way, here's my negatives and here's my positives. So it really is 2 number lines intersecting together. All right, some easy stuff way back when we saw pre-algebra. We plot points, and the points are called ordered pairs. O-R-D-E-R-E-D, ordered pairs. And we plot the ordered pairs on the coordinate plane. The order does matter. That's why it's called an ordered pair. X first, then Y. Always, always, always. The order does matter. All right, so we're going to plot some ordered pairs on this coordinate plane. They're already plotted, but we're just going to verify that they're correct. And we're also going to label them. This is going to be point A, this is going to be point B, this is going to be point C. So on a test or a quiz, if you have to plot a bunch of ordered pairs on the same coordinate plane, you need to label them as A, B, or C, or at the very least, give the coordinates right next to it, like is shown here in the diagram. So when x is -3 and y is 1, I start at the origin and I go to the left 3 and up 1. This is that ordered pair, -3, 1, that point right there. I called that point A. You might have seen this in geometry where you have to label each point on the coordinate plane. X is 2, y is 3. I'm going to plot this ordered pair right here. So I start at the origin and I go 2 units on x, right, on the x-axis, and I rise 3. I'm going to go up here for where the y value is 3. This is point B. And of course, this is negative 1.5 and negative 2.5. So x is negative 1.5, y is negative 2.5. This is the coordinates for point C. So, no rocket science there. Easy peasy lemon squeezy. All right, side 2. An equation in 2 variables contains both x and y. Like this equation right here. It's got an x and a y in it. So a solution to an equation as such would be an ordered pair that makes the equation what kind of statement do you think? Well, I'm going to give you a moment to think of it, and you can say it. I won't be able to hear you, but you can say it. And I'm going to guess that some students said that it makes it a true statement, and you are correct. Okay, so if it's a solution, it makes it true. So I'm going to ask you the question, is 3, 5, this ordered pair, a solution to y equals x squared subtract 4? Is it a solution? And you say, well, let me try it out. I'm going to substitute the 5 in for the y, the 3 in for the x. 5 equals, well, what's x squared? 3 squared is 9. 9 subtract 4 is 5. Yeah, so 5 equals 5. We say, yes, it is a solution. We'll write it out. 5 equals 3 squared subtract 4. 5 equals 9 minus 4 is 5. It works. So yes, it's a solution. The graph of the equation is the set of all points whose coordinates satisfy the equation. So since 3, 5 is a solution to this equation, we say that 3, 5 also satisfies the equation. We say the ordered pair 3, 5 satisfies. Y is equal to x squared subtract 4. Okay, because it makes it true. It satisfies the conditions. Now, a set of all points, if we have a graph of a circle, all of the points on the circle would make the circle's equation true. And so we're going to do a couple of graphs here. First one's going to be linear, and the next one is going to be quadratic. Now, I will tell you that in your homework, yes, you have to make a table of values. Okay? Make a table of values. Now, for this part, most students are like, I don't want to make tables. And then later on, when we do transformations of functions and I tell you you're not allowed to make a table, then all of a sudden you want to make tables. So, I don't know what to say. Just make the table of values. My example here is y equals negative 1/2 x plus 2. And I know you say that's in slope-intercept form and I could graph it without making a table, but you know what? Just make the table. Thank you. All right. So here's my table, x, and then my y. And I'm going to put the function inside. I know it's a function because it's a graph of a straight line. All right, I'm going to pick some x values, negative 2, 0, and positive 2. Now for linears, I'm okay with you using 3 points. You should try to spread them out a little bit. Really, what's going on here, and I'm going to tell you that I don't need you to show all this work like in homework because I think it's silly. Just do it in the notes, please. All I'm doing is writing the model here, the equation, the function, and leaving a space for x and substituting the x value in from my table. Again, I won't need to see this, and in fact, I'm going to show you something on the graphing calculator. I'm going to put a 2 in here. All right, so what do we got? Half of 2 is 1. Negative times negative is positive. So this is positive 1 plus 2, or 3. Folks, this is going to give me an ordered pair to graph. Negative 2, comma 3, right? When x is negative 2, y is 3. Okay? When x is 0, right, y is 2. And when x is 2, right, so half of 2 is 1. It's going to be negative 1 plus 2 is 1. So the ordered pair 2, 1 is found on the graph of this function as well. So now I'm going to plot these ordered pairs. So x is negative 2, y is 3, x is 0, y is 2, x is 1, y is, x is 2, y is 1. There we go. And I'm going to take a straight edge and draw my line. Folks, I don't want itty-bitty lines, okay? Just take a straight edge or something, and you know, you need arrows on your graphs because it continues. Now, I will show you on the TI-84, if you turn this thing on, you should always do second plus 712 to clear the memory. All right, I'm going to go into y equals, and I'm just going to type in parentheses, the negative down here at the bottom underneath the 3, okay, negative. And I'm going to do 1 divided by 2, because that's my slope, my negative 1/2. My x, if you haven't used this calculator before, x is right here underneath mode. Okay, I'm just going to hit that one time, and it substitutes the x right there in there for me. And I'm going to do plus 2. Okay, negative 1 of x plus 2. And I'm going to hit graph. I want to look at it. Ooh, look at that. It matches. It matches. All right. Now I want to get the table. And if you look here on my graphing calculator, right here above this graph button, it says table. But it's in blue, so I have to use this blue button here. So I click second, table. Okay, and there are my table of values. So I've got, I want to see what is y when x is negative 2. Now I'm just using these up-down arrows to move in my table. Okay, so when x is negative 2, y is 3. When x is 0, y is 2. There it is. And when x is 2, y is 1. So you can verify it on the table. And in fact, this would be enough for me on a test or a quiz. Put it in the graphing calculator. Again, I told you you don't have to buy a graphing calculator because you could do this without a graphing calculator, but this is going to be so much quicker, and you won't be able to use Desmos on your test or quiz. Just keep that in mind. All right. If you have questions on this, post a comment on the homework discussion, or ask a question in class. We've got one more example to do, and then that's going to end our video because we're doing these videos over 2 days because of the Chapter P test. All right, I'll do this one in a different color. I guess I'll pick red. All right, we're going to graph. Y is equal to 9 subtract x squared. Okay, so I've got x. I'm making a table. Now for parabolas, I really want you to have 5 points. Okay? So 1, 2, 3, 4, 5. All right. Y equals 9 subtract x squared is my function. I'm going to choose the x values. Let's do negative 3. Let's do negative 1 and 0, positive 1 and 3. Because remember with parabolas, and this is quadratic, x to the power of 2 is quadratic. Remember with parabolas, you do have symmetry. Okay, so I'm going to pick those values. All right, so this is y equals 9 subtract x squared. I'm just going to write all this out really quickly. Again, this is for the notes. on a test or a quiz. You know, if you don't have a graphing calculator, you're going to probably end up having to write part of this out. Okay, my first x is -3, my second one is -1, then I've got a 0 here, a 1 and a +3. All right, so square -3, remember you have to do PEMDAS. I can't distribute that negative in there first. All right, so I'm going to square -3 and get +9. So this becomes 9 minus 9, or 0. Square -1 is +1. 9 minus 1 is 8. This is 9 minus 0, or 9. This is the same thing. This is 1. 9 minus 1, or 8. And then 3 squared is 9. 9 minus 9 is 0. So my ordered pairs, I'm going to go ahead and plot them. -3, 0. X is -3, y is 0. Then I've got -1, +8. Then I've got 0, 9. And then I've got 1, 8. And then I've got 3, 0. Okay, and here is my parabola. It's upside down. So I'm going to, I like to turn my paper so I get a better graph. Come up there on that side. And make a nice U-shaped graph. You don't want it to be a V. It's not absolute value. I'm going to put arrows on my graph. And that's pretty much it. Now, I can type this into the graphing calculator as well. So I'm going to go second plus 7, 1, 2 to clear my RAM. Okay, and I'm going to hit clear 2 times, go into y equals, and I'm going to type in the function 9 subtract x raised to the power of 2. And I'm going to hit graph. There's my beautiful parabola. And I could verify the table. Second table, I want x values to be at -3. So I'm going to arrow up so that I can actually see the -3 in my table. When x is -3, y is 0. When x is -1, y is 8. 0, 9, 1, 8, and 3, 0. All can be verified on the TI-84. So again, you will need a table. If you have one of these calculators, type the function into it and grab the table. That's all I have for you today. We will continue Chapter 1, Section 1 notes after we get through Chapter P test. Have a great day.